In previous videos, we talked about the Fourier series of a function, and the function that we have a Fourier series of is going to be a piecewise continuous function defined on the interval from negative t to t. Now let's say that you have a scenario where you have a function that's only defined from 0 to t. So if f is only defined from 0 to t, then you can extend it to a function on the interval from negative t to t, and then you can make it periodic with period 2t. Now let me explain what this means. The best way to explain what this means is to look at an example. So let's say that you have a function that's just f of x equals x between 0 and pi. So here's 0, here's pi, and you have the function x. So it looks like this. I'll use a different color. Okay. And this function is only defined from 0 to pi. Well, if you have a Fourier series, you want to have it defined, you want your function to be defined from negative pi to pi. Okay, there are a couple ways to do this. So, first of all, extending a function literally just means defining a function from negative pi to 0 so that from 0 to pi it's the same as the function f. So there's trillions of ways of extending the function to the interval from negative pi to pi. I mean, you could do a straight line, you could do a squiggle, whatever, as long as it's a function, right? Not just a random graph, it needs to be a function. Then that would extend the function that's originally defined from 0 to pi and make the domain from negative pi to pi. And you just keep the function x from 0 to pi. So one way to do this is to make it periodic with period pi. So you can just take this part and just shift it to the left by pi. And if you do that, you end up getting this. So if you do this, this function now is periodic with period pi. And actually you can keep going. So you can go to 2 pi and negative 2 pi and just keep doing this, and it'll just go on forever. This would be the pi periodic extension of f. Now this function is neither odd nor even, right? Because if you look at the graph, this function does not have 180 degree rotational symmetry about the origin, right? If you imagine rotating everything by 180 degrees about the origin, you will not get the same graph. And it's not symmetric about the y-axis, so this is not an even function. So it's neither odd nor even, right? So this function does have a Fourier series, and the Fourier series will involve sine and cosine. So f is not even or odd, so its Fourier series. Now, technically f was only from 0 to pi, is only defined from 0 to pi. So you might call this function f tilde, like this. That's a very typical notation. F tilde is the extension, right? So it's only f when you zoom in and only look at the domain from 0 to pi. So f tilde is neither even nor odd, so its Fourier series involves sine and cosine terms. So what we're trying to do is we're trying to get a Fourier series of your function. So you want to extend it to from negative t to t and then look at the Fourier series. And ideally we would want something with a simple Fourier series. So instead of doing this, you can look at making it odd or making it even. So let's try to extend this function to make it odd. Okay. So we're back at the start where you go from 0 to pi and the function is just x. Okay, so this is your function f of x equals x from 0 to pi, not including 0 and pi. Well, to make it odd, we need to make it have 180 degree symmetry. So when you do that, you're going to get, can you try to visualize what you're going to get? What would it look like? Well, you need f of negative x to be minus, right? So you need f of negative x to be minus f of x in order for your function to be odd. So if your f of x is just x, then you need f of minus x to be negative x. Well, that's just going to look like this. Right. So this is if x is between 0 and pi. If your function is odd. Okay, so this is going to be an odd function, and we might as well define it to be 0 at x equals 0. So this function, this is just f of x equals x, right? On the interval from negative pi to pi. So this is the odd extension of f. Do we see what's going on? It's an odd function, right? This function is an odd function, and it's defined from negative pi to pi. And we just took the original function f, which is originally from 0 to pi, and then extended it and made it odd, while not changing it from 0 to pi. Now we can make this 2 pi periodic extension. Now we can make this 2 pi periodic. How do we do that? Well, see, this domain goes from negative pi to pi, so that's a length of 2 pi. And so to make it periodic, you just take this whole graph and just translate it to the right and to the left forever. So if you go from negative pi to pi, that's a length of 2 pi. So you add 2 pi more, so that would be pi to 3 pi, and then you just take the same graph. So it's just going to look like this. Yeah, well, it should be a straight line. It's just y equals x, except shifted, right, like this. And then you just go on forever. So if you subtract 2 pi from negative pi, you get negative 3 pi. And then you get the same graph, so it's going to look like this. Okay, well, it's supposed to be parallel, but you get the idea, right? Okay, something like this. See, I don't have enough space. Maybe negative 3 pi is out here. And so yeah, something like that, right? and it just goes on forever. So this would be the odd 2 pi periodic extension of f of x. So this would be our f tilde. F tilde is the odd 2 pi periodic extension of f. Now, when we look at the Fourier series of this, what's nice about it? Well, this is a odd function, so will it involve cosines or sines? If it's odd, let's see, how does it work? So the thing is that cosine is an even function, right? So when you do an odd function times cosine of nx, okay, so that's an even function, you get an odd function, and then the integral from negative t to t is going to be 0. So when you have an odd function, the Fourier series only involves sine terms. So the Fourier series of f tilde only involves sine terms. So that's kind of nice. So if and this Fourier series will give you f, oh no, not here, f from 0 to pi. So if you want, do you see what's going on? So if you want a Fourier series to represent the original function f of x equals x from 0 to pi, and you want it to only involve sine terms, then you would use this odd, you would take this odd function, so it's just f of x equals x from negative pi to pi, and then look at the Fourier series of that. If you looked at the Fourier series of this function, okay, this function here, f tilde, is also an extension of f, but when you look at the Fourier series of this, it's going to involve sine and cosine terms, because this f tilde is neither even nor odd. Now, when you restrict it, when you take your Fourier series of f tilde and look only at x between 0 and pi, you're going to get a series expansion of x. Okay, it's going to be different than if you had this odd periodic extension. Okay, so that was the odd 2 pi periodic extension of f. Now we can also have the even 2 pi periodic extension. So this is what you get when you take our graph. So we had f of x equals x from 0 to pi. So it looks like this. And to make it even, what do you have to do? Well, to be an even function, you have to be symmetric about the y-axis. So we're going to take this graph and flip it across the y-axis, and it's going to look like this. And then we can just even make it continuous by defining it to be 0 at x equals 0. Well, what is this function? If it's symmetric and from 0 to pi, or when x is greater than 0, it's just x. So this is the absolute value of x, right? So this even function, this f tilde, maybe we'll call it f sub even of x, is the absolute value of x from 0 to, from negative pi to pi. Okay, and this is the odd extension. So this is just f sub odd of x is x when x is between negative pi and pi. Okay, so like before, now we have something that's defined from negative pi to pi, except this time it's even, and now we just do the same thing to make it periodic with period 2 pi. You just take this graph and shift everything to the right and left forever. So your whole function, instead of making it just from negative pi to pi, okay, it's going to look like this. It's going to go like that forever. So here's where it is at -3 pi. And you can even just make it continuous by defining it at pi and 3 pi and -pi and -3 pi, etc. So this is your f sub even. Okay. This one here was your f sub odd. And when you look at the Fourier series of this, so the Fourier series of f sub even only involves cosines. It will have only cosine terms, so you're going to have to calculate the ands, but not the bn's. Okay, so we looked at the odd periodic extension, the even periodic extension, and there are other ways, as I mentioned before, there are many other ways of extending f of x. And then once you extend it, you can get the Fourier series, but the problem is the Fourier series of that periodic extension will contain both sine and cosine terms. So that's sort of the drawback of not using an odd or even extension. So for example, you could, so here's your original function again, f of x equals x from 0 to pi. I mean, you could define it just to be 0 from -pi to 0. Right? This is a perfectly good function that extends your original function f, and then you just repeat forever. So it's going to look like this. It just goes on forever. You can even fill it in here. And it just goes on forever like this. But the Fourier series of this will involve sine and cosine terms. Okay, so in the next video, we're going to look at what happens when you look at Fourier series of the even and odd periodic extensions. Those are called the Fourier cosine and sine series. So we'll take a look at that in the next video.